Number 5, it wants us to solve this, and it says use the method of factoring. So we want to factor this into the product of two binomials. And what does it have to be set equal to? Yeah, you must always, to do this, you always have to get it set equal to 0. So I need this 12 to move over. So the first step is I'm going to subtract 12. And now I have x squared plus 4x, take away 12 equals 0. That's the first step that I must do. I have to get it set equal to 0. Now I can factor this into the product of two binomials equaling 0, and that means either this piece has to be 0 or that one's going to have to be 0. So now we just need to factor it. Nice thing is the a value is 1, so all I got to do is look at that 12, which is a negative 12, and break it down. 1 and 12, 2 and 6, 3 and 4. Okay, I don't have to bust b because, again, it's just a 1 right there, so there's no busting b. This is just back to basic factoring from Algebra 1. So I need a negative 12, so one of them is negative, one of them is positive. So I'm looking at a difference. This has a difference of 11. This has a difference of 4 because, again, one of them is negative, so we're subtracting it, and this is 1. I need a 4. So I need to use the 2 and the 6. It says I need a what? Positive 4. Since you need a positive 4, you're going to need the positive on the bigger number, 6, and the negative on the 2. Negative 2 plus 6 is positive 4, and negative 2 times a positive 6 gives you the negative 12. So this factors down to an x minus 2 times an x plus 6. Now, like I said, this times this equals 0. That means this guy has to be a 0 or this guy's a 0. One of them has to come out to be 0. That's the only way two numbers can multiply to give you a 0 answer. So I add 2, x is 2. That's one solution that will make this equation up here true. I then subtract 6, or my other option is negative 6. If I plug negative 6 into there and there, boom, it'll make it true. So those are our two solutions. Technically, the parabola is crossing at positive 2 and negative 6. That's the x-axis. That's where it's crossing. That's literally what we're finding.